This video is about lists in Python. Lists represent what in mathematics we normally call a sequence, so they have an order and they allow repeated elements, unlike sets. In Python you can create a list using square brackets. So in our first code cell here, we create a list called mylist, whose elements are 1, 2 and 3, and another list, whose elements are something more complicated. Python lists don't have to have numbers as elements, they can have anything as an element. So the second list has a string, then some numbers, then another list, and then a function. Absolutely anything at all can be a list element in Python. A lot of the same functions for other variables can be used for lists. For example, you can compare two lists to see whether they're equal. Here we check whether my list is equal to the list containing 1, 2 and 3. Of course it is, so we get the answer true. But lists, as I said, are like sequences in mathematics. The order matters. So my list will not be equal to 3, 2, 1. You can see that as false. We can join two lists together with the plus operator, just like we join two strings together with the plus operator. That's called concatenation. So when I concatenate 1, 2, 3 with 4, 5, 6, I get 1, 2, 3, 4, 5, 6. There's also a special operator for adding something to the end of a list, which is more efficient than just adding on another list at the end. So if you do mylist.append 4, that modifies my list by adding 4 at the end. If I run this code cell, then at the moment my list is equal to the list 1, 2, 3, but when I run the append command, it will get a 4 on the end. So line 2 will print that out, and as you can see, we get the list 1, 2, 3, 4. So that function application looks a bit strange with a dot there. You should think of mylist.append 4 as meaning apply the append function to the arguments mylist and 4. So append is a function which puts an element on the end of a list. Functions which you call in this way are called list methods. We'll learn a bit more about those things when we learn about classes. But for now, when you see something like mylist.append and then a number 4, you should think of that as applying an append function to the inputs mylist and 4, and what it does is add the 4 to the end. The length of a list can be found with len, so here is len of the list containing 1, 2, that should be 2, and here is the empty list, so the length of the empty list is 0. So the empty list, of course, is just written by a pair of square brackets with nothing between them. Once you've made a list, it's useful to be able to access its ith element for some value of I. You can get the ith element of a list A by using a square brackets I, but there's an important thing to remember, which is that Python lists start at position 0. At the moment, my list is the list whose elements are 1, 2, 3, 4. So the 0th element will be 1, and the first element will be 2. This is a really easy way to make mistakes in Python, so it's important to remember that Python lists start with position 0. There's a special notation for the last element of a list, which is that you can ask for list index number -1 by putting -1 in square brackets. That gives you the last element. As I said, at the moment my list is the list 1, 2, 3, 4, so my list -1 will be the last element, which is 4. You can also take slices of a list, just like we took slices of strings. If you define A to be the list whose elements are the strings A, B, C, D, E, F, G, H, I, then you can take a slice of that list by using A and then in square brackets I:'J. And what that gives you is the list consisting of all of the elements of the list between index I up to index j-1. So yes, that is really right. We go from I up to j-1. So here, on line 2 there, I've asked for A square brackets 1:6, which will give me the elements of A with indices 1, 2, 3, 4 and 5. So that will be B, C, D, E and F. You can see that really is what we get. So again, you have to remember that Python has a few quirks around how it deals with list accesses. The first is that lists start with position 0, and the second is, like the range command, if you ask for a list slice between I and j, then you'll get the indices from I up to j-1. there are many, many, many more list functions. If you'd like to see the documentation, you'll find a link in the notebook, which I'll post on Moodle. Here it is. It's a list of the official Python list documentation, which will give you dozens of other functions, including sorting a list, deleting elements of a list, reversing a list, and so on. Let's write an example function that uses lists. Previously, we looked at how to find the divisors of a number and print them out. So, for example, if you wanted the divisors of 12, that would be 1 and 2 and 3 and 4 and 6 and 12. So we wrote a function which would print out the divisors of that list. But what if we actually wanted to work with the divisors? We can't work with stuff that's printed to the screen, because once it's printed to the screen, you can't use it again. So a sensible way to get hold of all the divisors of a number will be to store them in a list. So we'll write a function which has as its input a positive integer n and has as its output a list of the divisors of n. This is the code cell where we're going to write the function. A very common thing for Python functions is to write at the start of the function a comment explaining what the function does, specifically what its input and what its output is. This kind of comment is called a docstring, and it's a special comment that we've not seen so far. The way you write it is by using 3 quote signs at the top to begin the comment and 3 quote signs at the end to end the comment. That's like the hash key syntax we've used for comments before, except that when you use these triple quotes, it allows you to have comments which go for multiple lines. So it's useful when you want to write a longer comment like this one explaining what your function does. And if you're writing any even slightly complicated function, it's a very good idea to document with a docstring like this one what are the inputs to your function and what will the outputs be, so that in the future you can understand easily what the function is supposed to do. That said, let's start writing our function. So what should we do? Well, we want all the divisors of a number n. So we're going to use a for loop to do this, because it would make sense for us to check all the numbers between 1 and n to see if they're divisors of n. So we'll have to use a for loop to do that. But what we'd like to do is store those divisors in a list. So to add something to a list, we can use this append function, but we'll need an empty list to begin with. So let's start by creating a variable which is going to hold the output of our function, and initially it should just be the empty list. Next, we'll create our for loop to check through all of the numbers between 1 and n and see whether they are divisors of n or not. So we'll do for d for divisor in range. Well, what should it be? Pause the video, tell me what I should put there. Okay, well the answer is you need a 2 input range function, because I don't want to start at 0. If I start at 0, I'm going to be checking whether I can divide n by 0, and division by 0 isn't allowed. So I must start at 1. And I want also to end at n, and if I want to end at n, I need n plus 1 here, not n, because you'll remember that range AB produces the numbers from a up to b minus 1. So if we want to stop at n, we have to have n plus 1 as the second input to our range function. So now we're inside the for loop. What do we want to do? Well, we need to check if d divides n, and if so, add it to our list of output. So we need a conditional. If d divides n, the way we do this is with the % command. So if n%d equals 0, remember n%d is the remainder when you divide n by d. So asking for when the remainder is 0, that's equivalent to asking when d divides n. n%d is equal to 0 if and only if d divides n. So let's add a comment to remind ourselves what this is doing. So this is saying if d divides n. It's always a good idea to add comments to code you're not quite sure about, or that is a little complicated, so that when you look at it in the future, you can see what it's supposed to do. It also helps in debugging your programming, so finding when there's a problem, because if you see a line that's supposed to check whether d divides n, but it looks as if it does something else, then that's a good indicator that there might be a problem there. So what should we do? Well, if n is divisible by d, we need to add d to our list of divisors. So our list of divisors was called output. So what I should do is do output.append d. That's all I want to do. if n is not divisible by d, I don't want to do anything at all. So I don't need an else clause in my if statement because I don't want to do anything if d doesn't divide n. And that's also all I need for my for loop. So the last thing I need to do is simply output the list of divisors that we've made. So we should use the return command to specify the output of our function, and it should be this variable output. Okay, that's the function done. So now we've defined this function, let's see if it works. So what should the divisors of 5 be? Hopefully 5 is a prime number, so the only divisors should be 1 and 5. Let's see if it works. Yep, there we go. We'll try it with 12. 1, 2, 3, 4, 6 and 12. Yeah, this seems to be working. Okay, we're done.